This tire alone is taller than most people. The driver sits higher than a two-story building. And one single full load can weigh more than hundreds of family cars combined. So why do mining companies build trucks this ridiculously huge instead of just using more normal trucks? You might think the answer is simply because mines need to move a lot of rock, but the truth is much more calculated than that. In the world of high-stakes extraction, the real reason for this scale is that one tiny efficiency change can decide whether a mine makes money or loses money. This is not just about being big for the sake of it. It is about the brutal reality of industrial physics. By the end of this, you will understand why these mechanical titans are the only things standing between a profitable venture and a multi-billion-dollar failure. To understand these giants, you first have to realize that an open-pit mine is not just a big construction site. It is a massive man-made landscape that often looks like it belongs on another planet. These pits can be kilometers wide and hundreds of meters deep. They are essentially inverted mountains. In this environment, the logistics are staggering. These trucks are not just driving across a flat lot. They are often crawling from the very bottom of a deep pit all the way up to a processing area, a waste dump, or a primary crusher. This route is not a quick trip. It is a long, steep, dusty, and incredibly repetitive journey that happens 24 hours a day, 7 days a week. These trucks are not carrying generic dirt. They are carrying heavy ore, dense waste rock, and abrasive material that must be relocated constantly to keep the operation alive. But here is the problem that keeps mine managers awake at night. If the truck is even slightly too small for the job, the entire mine starts to slow down. And in this business, a slow mine is a dying mine. This brings us to the core of the operation. Mining is a tons per hour business. In almost every other industry, you might measure success by the quality of the finish or the speed of the delivery. In mining, the only number that truly matters at the end of the day is how many tons of material you move from point A to point B within 60 minutes. It sounds simple, but the math gets complicated very quickly. You might think that buying 50 regular dump trucks would be easier and cheaper than buying 5 massive ones. After all, if one small truck breaks down, you still have 49 left. But the reality is the opposite. More trucks mean you need more drivers, which dramatically increases your labor costs and human resource management. More trucks mean more fuel consumption per ton moved because you are moving more deadweight engine parts relative to the cargo. More trucks mean more traffic on narrow haul roads, leading to congestion, delays, and a significantly higher risk of accidents. One gigantic truck can replace an entire fleet of smaller vehicles, doing the same route again and again. This consolidation reduces the chaos and maximizes the output of every single heartbeat of the mine's operation. And this is where the size starts to make serious financial sense. The real reason for the existence of these machines can be summed up in 3 words: cost per ton. This is the key idea that dictates every design choice of an ultra-class haul truck. Mining companies do not just look at the price tag of the machine, which can easily exceed $5 million. They ask a much more important question: how much does it cost to move one single ton of rock? If a truck costs $5 million but moves material so efficiently that it pays for itself in a few years through fuel savings and reduced labor, it is considered a bargain. This concept of mining efficiency is why companies like Liebherr market machines like the T284. They are not selling a truck, they are selling a lower cost per ton. A truck that can carry 400 tons in one trip uses less fuel per ton than a smaller truck carrying 40 tons over 10 trips. When you multiply that tiny saving across millions of tons of rock moved over 20 years, the giant truck becomes a literal money printing machine. The goal is to move as much as possible while touching the material as little as possible. Now, let's talk about the most iconic feature of these machines: the tires. These are not just oversized versions of what you have on your SUV. A single tire can cost upwards of $50,000 and weigh over 5 tons. They are enormous because they have a massive job to do. They have to carry the insane weight of the truck, plus a 400-ton payload without sinking into the ground or shredding instantly. These tires help distribute that immense pressure over a larger surface area so the truck doesn't crush the very road it's driving on. They are also designed to absorb massive impacts from falling rocks and to survive the extreme heat generated by constant flexing under load. However, the tire is also one of the biggest limiting factors in engineering. You cannot just keep making the truck bigger forever because we are reaching the physical limits of what rubber and fabric can support. If you make the truck any heavier, the tires would simply disintegrate from the heat and pressure. The tire is not just a tire, it is one of the main reasons these trucks have a physical size limit. These vehicles lack speed despite their enormous engines. A Liebherr T284's top speed on a flat road is 64 kilometers AH, or 40 miles per hour. Fully loaded and crawling out of a deep pit, they move much slower. They're weak, but not slow. Speed is less critical than regulated, consistent movement under tremendous weight, hence they're slow. Normal trucks are built for public highways with speed limits and traffic flow. A mining truck is developed for a private industrial world where the road, load, and route are customized. They require huge torque to haul 600 tons up a 10% mud grade. Speeding is harmful and wears out expensive components quickly. Relentless momentum is key. Remember that the vehicle is just one aspect of a larger system. A mining dump truck fits nicely with the rest of the mine's equipment. Match factor is what engineers call it. Filling a big truck requires a big excavator. If the excavator is too tiny, the truck idles for 20 minutes before loading, wasting fuel and time. The vehicle must queue if the end crusher cannot handle a 400-ton dump. Truck size determines haul road width, maintenance bay size, and fuel system capacity. Changing the truck size requires changing the mine. A mining dump truck is factory equipment that must fit exactly into the Earth's assembly line. However, bigger is not necessarily better. Large-scale trade-offs are significant. The purchasing price is just the beginning. Specialized tires are expensive and scarce worldwide. Some trucks consume hundreds of liters every hour. Maintenance requires large cranes and skilled workers. These vehicles must be transported in dozens of sections on flatbed trailers and welded together on site over many weeks before being driven to the mine. A large truck breaking down in a small pit can shut down the entire business, costing millions of dollars in output daily. A huge truck is profitable only if the mine can keep it running. Truck overhead costs will eat up all the profit if the mine or haul lengths are too tiny. The truck is huge because the mine big. The same truck in the wrong mine is a costly blunder. The next generation of giants may not grow, but they will become wiser. Autonomous haul trucks that use GPS and radar to maneuver better than humans are already appearing. Electric driving systems and tram assist programs connect trucks to overhead power lines, like huge trams, to save gasoline while rising out of the hole. Their future ambition goes beyond size. They must transport more material with less fuel, downtime, and risk to fewer people. The dumb giant is dying, while the high-tech, sustainable titan is rising. Why are they so big? Actually, mining rewards scale more than practically every other industry on Earth. Moving a mountain requires fewer trips with a larger vehicle. Fewer trips mean lower ore extraction costs per ton. Lower cost per ton means more lucrative mines, allowing us to get metals and minerals for smartphones and skyscrapers. These vehicles are not toys for huge machine fans. Massive diesel-powered calculators on wheels are designed to convert mountains into numbers. Would you rather drive one of these trucks all day or stand next to a tire to sense its size? Share in the comments.